So let's discuss this collection framework that we have in Java library. So you see that in some places here we use word hash. Hash in computing and in mathematics is referring to a function that takes a certain value and computes a unique hash value. So basically a function that takes one thing as an input and returns another thing as output. So hashes can be used in security, in cryptography, in communication, in data compression, in some sort of like checking control sum of certain parts of data. And in our Java library, hash functions are used for data indexing. So sometimes instead of just having a collection of values like this, instead you want hash values of your elements to be stored in this collection, and these hash values can be primarily, we can check for their uniqueness. For example, a set here represents a set of unique values. So for instance, if this is a set of integers, and so I have my set of integers right here, and I create this collection set of integers, and I populate it with values 1, 5, and 8, something like this, right? So I have three numbers stored in my collection, which is named set, specifically hash set right here. In our Java library. And then if I want to insert a new element, and this new element is element 5, right? So this is brand new element that I would like to insert into this collection. So hash set will automatically check whether this value is already present in this set, and attempt to insert this new value 5 into collection of these numbers will be ignored. So this will have no effect because the value is already present. However, if I insert new value like 3, okay, of course you can see that 3 is not present in this hash set example right here. So 3 naturally will be added as a new element, and collection will continue to grow as a result because 3 was not present here originally. So hash set is a set of unique values, and I suggest that you primarily just interpret the idea of hashing in a collection framework as unique map and unique set. Okay, so hashing something generates a unique value which can be checked. Of course, with integers, integers themselves don't require any kind of conversion from value 1 to some kind of unique value for 1, because 1 in itself is unique value, 5 is a unique value. So here with integers is pretty obvious. But with more complicated objects and data structures, hashing would require additional work to produce some sort of unique value. And so this is an idea. So every time you have a hash part of the name of a collection, remember that this is something about uniqueness, a map of unique keys of elements, or unique set of elements. Okay, so if this hash set was a set of strings, we could have strings ABC, DEF, and XYZ, and if we attempt to insert new string which is ABC or DEF or XYZ, it will be ignored because the set of hash values for existing strings already contains information about these objects. But if we insert something brand new into this set, it will be accepted and expanded. So the hash set is not sorted, so the values are not sorted. You can see that 1, 5, 8, and 3 are present inside this hash set of integers that I try to populate. They're not sorted, but they are unique. Okay, so each value here will always be unique. And sometimes it's very nice to have a set. So for instance, you can keep track of customer phone numbers, and you can always find out if the phone number is already inside the database, and therefore by phone number you can find out the name of the customer. Okay, so it makes perfect sense in indexing to be able to maintain a unique set of values. So this is a comparison between the list and a set. List is just very generic collection sequence of elements, not sorted, just non-unique. You can insert as many elements of the same value as you like. All right. In a set situation, the idea is that the set is a set of unique values. There are also other types of collections like multi-sets in a library, but I'm not going to discuss them right now. The mapping is designed to do the following. So it's always the case that you have a collection of elements, some kind of data objects or business objects in your application. Okay, so these are my objects right here, and they contain a lot of data attributes. Okay, so they can be storing, like for instance, it could be customer information, customer ID, customer name, customer phone number, customer account. There's all sorts of attributes. But and I can have really a lot of these objects in memory. I can have thousands of them. So if I need to be able to search for a customer with a specific account name, it would make perfect sense to create a map of account numbers right here, right? So I could have account numbers, and they could be pointing to specific customer like this, and this way account number becomes a key, right? So this is a key, and this becomes the value. And so the idea behind maps is that you have a set of keys, unique keys, which pointing to the values. And this is an idea of mapping, and therefore any map, hash map or tree map, is essentially a collection of these entries like this, right? So the container such as map will have entries of key and value pairs, right? And they're called entries. And altogether, this is going to be placed inside the object that is called something like a map. Okay, so this is the idea of a map. When you insert something into the map, you have to provide the key and you have to provide the value. The keys are automatically organized as unique keys, and whenever you query this container of these mapped keys to values for a specific key, it will give you an instant access to this value. So this becomes very beneficial when you have a large collections of data elements or business objects that will take a significant time to just sequentially search for a specific object with a specific account name if you were using an array list. If you put these business objects like customer on the list, then you can just ask the user to provide the key and instantly or nearly instantly get access to specific value object and start using it. So that's the idea of map container. So map container always has a pair of a key and value type of entries, and altogether these entries are placed inside the container, and as a result you have this mapping organized by keys, and that's the type of collection. So unique set, sequential organization of elements, and key value pairs inside maps. So these are the types of containers that are generally present right here, and you can see that this is from this organization of all sorts of objects that are present in this Java collection framework. You can pick the right one and start using it. Very popular are hash maps and array lists. They typically have good performance, and hash set if you need a set. So these are primary choices. If you need to have your keys always sorted, then you pick the tree map. The tree map difference between the hash map and tree map is that all the keys are automatically sorted. So we'll have some examples of all of these types of collections in our future demos.